Hey guys, welcome back to my channel and good evening. Um, this is my second try, first time in a while that I had to record again, but it is what it is. Today we are going to explore the case where it's not specified to us that we have to use nodes and graphs. Um, and we discussed that yesterday, right? So sometimes it's obvious that we have to use DFS, BFS when we're provided with um, what's it called? Adjacency matrix or adjacency arrays or list of arrays, or they give us the node with the test case with pictures. But sometimes it's not that simple. So in this case, let's look at the example question. This was the question that was also featured in, yeah, I'm already sharing the screen, in Meta interviews, Amazon interviews. It's a medium difficulty question, but it goes alongside the question that we did yesterday, which was trying to find the shortest path to the end node from the given node. In a sense that we also use BFS. Um, but yeah, let's define the problem first. So we are supposed to open the lock. We have a lock in front of you of us with four circular wheels. So we have four digits, and we are trying to find the target digit um, in the shortest amount of path. So when it says here that we can only turn one wheel, one slot, it should already click that we have to use some kind of node algorithm. And in this case, it will be BFS because we have to find the shortest path. Um, when we're traveling by level, it iterates um, over all the nodes and searches all the paths, whereas DFS, it can miss some nodes. Um, yeah, so let's look at the test case really simply. So here you can see that it can only move, it can increment or decrement one at a time for one digit. So 0000 can move to 1000 and then 1100, so on and so forth. And it reaches the target number, which is 0202. And it returns the output of 6, meaning that it took 6 changes, minimum total number of turns required to open the lock. And we have to look at the edge case. In this case, it's dead ends, which are also provided as a list of numbers that um, if the lock displays any of these nodes while traversing through all the nodes, so traversing through all the digits, then it would automatically return -1. Or if there is a case that um, while moving through target, um, we have to go through one of these dead ends, then we have to return -1, and that's shown in test case 3, where to reach 8888, we have to somehow go through 8889 and 8887, which is not possible, right? Logically. So in those cases, we have to return -1. So I've already written what we need for this question. So we need, first of all, the helper function, like yesterday. We used the helper function valid yesterday. In this case, we need a helper function called neighbors. The name we can specify at any time, but this function, what it does is, excuse me, this function generates all possible combination of the lock that can be reached from the current combination by turning one wheel either up or down. And it iterates through each of the four digits of the lock, changing each digit to either one more or one less. And yeah, now we need also to check to mark the nodes or digits that we have visited, right? Because we're trying to find the shortest path to the target number. So that will be initialized with a set. We also have to initialize a queue, just like how we did yesterday, because we're going to use a BFS loop later. And this is going to be initialized with a starting number of 0000 and step count of 0. Thirdly, we need BFS loop itself. So we dequeue a combination and check if it is the target. We remove the number from its list of array. So a queue, first in, first out. And we enqueue the neighbor node if it is not already added to the scene set. Yeah, and each neighbor that has not been seen yet is added to the queue with step count incremented 1 and marked as seen. Now at the end, we need the end condition, which means that if the queue is exhausted without finding the target, the function returns -1. So it indicates that the combination is unreachable. Now, let's start coding. What do we need? First of all, we need the helper function, which will be the neighbors. So node, this function generates all possible combinations, like I said, that can be reached from the current combination by turning one wheel up or down. And this case, answer is an empty list. Oh, whatever. I in for each of the 4 digits in the lock, we convert the digit into an integer first. So that would be int node I. And now we calculate the new digit by either adding or subtracting 1 with the wrap around using modulo 0, modulo 10. So that would be 4 change in -1 or 1. X equals num plus change modulo 10. And answer append node slicing plus string x plus node I plus 1. Yes. And we form new combinations here by replacing the current digit with the new digit, right? Yes. Now, we do also the initial checks and setup. So how we do that is if we check if the initial combination 0000 is in the dead lens. So dead lens and return -1. We did number 1, we did number 2. Now number 3, we have to initialize. No, we haven't initialized a queue yet, so we have to initialize a queue. So that will be dequeue zero and 0. And seen is a set of dead ends that we want to mark. And yes, seen dot add 0. So here we initialize the queue for BFS with the starting combination 0, 0, 0, 0 and a step count of 0. We initialize set of dead ends to keep track of visitor combinations. And we start with the dead ends and add 0, 0, 0, 0. Now we have to add the actual BFS loop. So while queue, when the queue is not empty, we continue the BFS, and just like yesterday, node steps equaled queue pop left. If node is a target, if the dequeued combination is the target, then we return the number of steps taken to reach it. So that would be steps. If no, for all we generate all possible neighbors of the current combination using the neighbors function here. So that would be for in neighbors node. If neighbor not in scene, then scene dot add neighbor. We append for each neighbor if it has not been seen before, we mark it as seen when we visit it, and we enqueue it with the step count incremented by 1. So we add it we enqueue it, and then we add it with 1, right? And then if not, we return -1, I think. Let's try this. Node steps -1. Too many values to unpack. While queue, node steps. Let's start from the beginning. So if range is 4 for change, and -1, 1, modulo 10, and node, and return -1. Queue it, scene, set dead ends, adds while queue, node equals steps, queue pop left. If node is equal to target, we return steps for neighbor and neighbor's node. Neighbor not in scene. So add neighbor, neighbor, and we return -1. What time is it? Okay, we still have a bit of time to upload this. Too many values to unpack. Expected 2. Hmm. Wait. Yeah. Step count shouldn't be inside the quotation mark. Let's try this. Okay. Strength. String X node. And supported type. I plus string X plus node I. Ah, fuck. Node type is not iterable. Neighbor and neighbors node. Answer dot append node I. Wrong brackets. We don't need this. We don't need the closing bracket here as well. Come on. Num plus change. We return the steps, neighbors and neighbor. Neighbors, if neighbor not in scene, and we append the neighbor two brackets. Non-type object. While queue node steps. If node is target, we return steps for neighbor in neighbors node. Neighbor in neighbors. Neighbor. Neighbor not in scene. Scene.add. Queue append. Bore steps +1. And we return -1. There's something wrong with the helper function, I guess. Node answer. x equals numbers change modulo 10 answer dot append. And this doesn't make sense. Oh wait, we haven't returned the answer here. We haven't returned the answer. Jesus Christ. Yeah, guys. So that was basically it. Um, yeah. That was it for BFS and graphs and graphs. We're going to go through all the questions when we um, finish algorithms. But until then, we're gonna move on with the algorithms. So tomorrow, I'll probably be doing something with heaps because that's next in line. But anyways, if you have any questions or comments, leave it down below this video. And thanks for watching. I'll see you guys tomorrow.